So earlier we talked about the F-test. So if you use the F-test to compare two sets of data and it passed the F-test, your next step is going to move on to the T-test to compare if it is significantly different or not. Okay, but there are several different types of T-tests, and not all of them always begin with the F-test. So let's start. What is a T-test? It allows us to compare either one data set or another if their averages are significantly different. Okay, but not just that. You can compare your data to the known value. So if you're testing a sample that has a correct value and that correct value is known, you can compare your data to how were you significantly different than the real answer. And that is actually going to be using a t-test, which is just the confidence interval, which we talked about. So we're going to do an example of that, how we use the confidence interval to see if your answer is significantly different than the right answer. Okay, so that's one way to use the t-test. A second way to use the t-test is you collected two sets of data from the same sample using two different methods, and it's already passed the F-test. Then we're going to then use the t-test to compare to see if their averages, their means, so more like their accuracy, are significantly different or not. These are the two we're going to focus on. There is a third way to do the t-test, which I'm going to mention, but we're not going to even practice. It's failed the F-test. So you've already used the F-test, and they are significantly different, but you're desperate because this is your last hope. There was still that 5% chance based on the confidence. F-tests were only 95% confident that the F-test would have told you that it was wrong, but really it was right. So there's a way to handle that, to do the t-test, that the F-test told you they are significantly different, but you're crossing your fingers and really hoping that it was in that 5% confidence, that, instead of being 95% confident, or instead of being 100% confident, we were only 95% confident. So as far as we're concerned, if something fails using the F-test, we're going to scrap it and start over. We're going to say that it fails. And by fails, I mean they are significantly different, so that our goal is to see if they are the same. Okay, so we're going to start at the top and work our way down with step number 3, where it fails. If they are significantly different from the F-test, I'm going to show you what it is, and we're not going to even practice it. So let's do I have a known value. I know what the correct answer is, but I didn't know that before I collected my data. So I want to compare my data to that known value and see if they are significantly different or not. So this is using the confidence interval. Okay, so what we're going to be doing, the way we use the confidence interval, we just practiced using the confidence interval. So I actually have the exact same data values that we used when we practiced the confidence interval, but what I've added is what the true value really was. So the confidence interval, using this equation, we change nothing about how we do it. We would take the average value, put it in for the mean, plus or minus. The t-value came from the table at 95% confidence with 3 degrees of freedom. The t-value was 182. Yep, 182. So 3.182 would go in the t-value. S is 0.0004, and the square root of 4 down here. So it was 1002925 molarity, plus or minus 0.00070. Oops. I'm writing up a hill, down a hill. 7027 molarity. So the range, I went ahead and took 0.1002925 plus 0.0007027, and what I got was 0.100993. And when I did the 0.1002925 minus 0.007027, I got 0.099587. Okay, so that's my range. Mu is somewhere, we're saying is somewhere within that range. Well, I'm telling you that the real value is 0.1100. So the way we're going to test this, does that fall within the range that we calculated? Well, 0.1100 is above the range we calculated. So that means my data and the true value are significantly different. If the true value falls outside of the confidence interval, then it didn't work. If the true value falls within the confidence interval, then it did. Okay, so again, the t-value came from that table. And if the range of the confidence interval includes the known value, then the results agree that are not significantly different. If the known value falls outside of the confidence interval, then they are significantly different. So since this was my range from the confidence interval and this was the true value and it did not fall within that range, then that means it didn't work out. My data was not close to the true value. So they are significantly different. Okay. Again, you would use the confidence interval equation when you have the known value. And if you're going to test this, I'd have to tell you in the question what the known value was, like I did here, where I said the true value. I would also have to tell you the percentage, which I told you here, but it wasn't in writing, the 95% confidence. So this t-table we'll still be using for the other two versions of the t-test. So what happens if this time we don't have a true value, but I have already done the f-test because I took my data, or I took my sample and I tested it 2 different ways, and I'm trying to compare if those 2 different tests, how they compare to each other. So first, it's already passed the f-test, saying they are not significantly different based on their precision. So now we need to compare them based on their averages, based on their accuracy. So there's 2 different calculations that I have to do. Well, the most important is we have to do the t-calc. We have to calculate what the t-value is. And a lot like the f-test, we're going to then compare the calculated t-value to the table t-value. But before I can do that, one of the terms in here is the S-pooled. It stands for the pooled standard deviation. Okay, and so this is the equation for the pooled standard deviation. S1 and S2, just like with the f-test, stand for standard deviation 1 and standard deviation 2. N1 and N2 stand for the number of trials in both dataset 1 and dataset 2. Okay, so before we can calculate the t-calc, we have to first calculate the S-pooled. These equations for all these statistic things, the confidence interval, the f-test, this t-test, these are always going to be given to you. They're a handout that can be found in Canvas. It'll also always be given to you for any exam that uses these. You'll be expected to do them in lab as well, but in lab you can always reference the handout. So the handout will include the equations and the tables. What won't be told to you on the handout are when to use what and what the final answer is. And by final answer is you telling me if they are or are not significantly different from each other. Okay, so let's do an example with this, comparing our 2 sets of data. Just like with the f-test, if the calculated value, the t-calc, is greater than the t-table, then they are significantly different. And if the t-calc, and show the other one, well, if the t-calc is less than the t-table, then they are not significantly different. So here's my data. So this one, we have a new way to measure the iron 3 ion. We're comparing the reference method, the way that we know works, with this new test method, and these are the results that we got. So I've already calculated the average, this should have a bar over it, for the 2 data sets, and the standard deviations for the 2 data sets. And it's already passed the f-test. So we're not going to do the f-test right now. You're going to trust me that it's already passed the f-test. So we're going to do the t-test on this. And so we have to do the t-calc to calculate the t-value. But before we can do that, we have to do the pooled standard deviation. So the important values that are given here, the average value and the standard deviation value for this trial or for this method, the average value and the standard deviation for this method. But the other things we're going to need to know, the number of trials. And it didn't tell us, but 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. We can count based on the number of data points, how many things. So these are the 3 pieces of information we need: the average, the standard deviation, and the number of trials for both methods. So let's start with the S-pooled equation. So this is what the S-pooled equation looks like. Stealing this from a couple slides ago. S1 squared times N1 minus 1 plus S2 squared times N2 minus 1, and it's all over the square root, divided by N1 plus N2 minus 2. So I'm going to start by just plugging in values. So S1 was, from the last slide, 0.6728 squared. The number of trials was 6, so minus 6 minus 1. S2 is 0.3236, which needs to be squared. The number of trials is 5, so 5 minus 1. And then the denominator, 6 trials plus 5 trials minus 2. and then square root is over the entire thing. So I didn't break this down into individual steps, but when I finished my math, the value that I got was 0.546. That's my S pooled. Okay. So I have my S pooled. Now I need to do calculate my T value. So the equation for that, well, average of 1 minus average of 2, absolute value, over S pooled, which we now have a value for, times the square root of N1 times N2 over N1 plus N2. So I'm looking back at the data values. 19.65 minus 19.24 are subtracting my two averages. My S pooled value is this 0.546 number that I just solved for. And then the square root of, 6 times 5 over 6 plus 5. So, do my math. And what I got for T-calc is 1.24. So I did this math and I got 1.24. Okay, so that's my T-calc. That's awesome. To know my answer though, to know what is true, I need to know the T-table. Okay, so I can compare them. I have to know the T-table. So let's go back to the T-table, or this. So I'm going with 95% confidence. Okay. If I don't tell you otherwise, you're just assuming it's 95% confidence, especially because the F test is only at 95% confidence, so I try to stick to 95% confidence. Now, I have to know the degrees of freedom. Crap, there were two different experiments. One had 6 trials, one had 5 trials. Well, we have to put them all together, so it would be 6 trials and 5 trials mean a total of 11 trials. To do degrees of freedom, though, I'm going to have to subtract 2. Or you can think of 6 trials had 5 degrees of freedom. 5 trials had 4 degrees of freedom. Added together, that's 9 degrees of freedom. 2.262. So the degrees of freedom for the t-test, you're going to do the degrees of freedom of one data set, degrees of freedom of the other data set, and then add them together. So 2.262. 2.262. So when I look at this, T-calc is less than T-table. So with 95% confidence, they are not significantly different. So if this already passed the F test, and now I call this passing, when they're not different, passed the T test, then it's like, oh, good, this new method, we should be good to use this new method. It works statistically no different than the other test. So again, a question like this, you would be given the data set. You would be even told to use the t-test, but you would have to recognize that you need to use this version of the t-test, that you need to calculate t-calc, and that you need to get the t-table value. And most importantly, once you have those numbers, you analyzed it by saying they are not significantly different. So there's points with all of this on there. But again, you're not memorizing the equations. So that's good news. So again, you'll be given this table as well. The last type of t-test is the one that you're not going to be asked to do in the homework. You're not going to be asked to do on the exam. I'm just mentioning it. So it failed the F test. The F test said that they were significantly different, but you're hoping that it was wrong. So you're going to go ahead and do a t-test anyway. So these are the equations to follow for this. To do the t-calc, you would follow this. You have to do a little bit more work to figure out degrees of freedom. And then you're just using the t-table and comparing the t-calc and the t-table value, using the same rules that we followed on this last one, where if the t-calc is greater than the t-table, they are significantly different. If the t-calc is less than t-table, they are not significantly different. So that's the t-test. So the two ways, again, you're going to be expected to handle this are if you are given the true known value and then a data set. You're going to be expected to be able to compare those two to see if they are or are not significantly different, and that's using the confidence interval. Or if we have two sets of data, you're going to first use the F test, and if they pass the F test by saying that they are not significantly different, then you will move on to the T test, calculating the S pooled and calculating the T calc, and then comparing that to the T table to determine if they are or are not significantly different.